Hello everyone, welcome back to my YouTube channel. Today we are going to answer one of the most asked questions. What actually is AI? And I don't mean a dictionary definition. I really mean how does it work? How is it trained? What's inside it? And why does it feel so different from software we used before? By the end of this video, you'll understand AI, machine learning, large language models from the ground up. So let's get started. So, what is AI? At its core, AI is about building systems that can do things that normally require human intelligence. Things like understanding language, recognizing patterns in data, making decisions under uncertainty. Now, here's something important that most people miss about the history of AI. Earlier, AI systems were narrow. You would build one model to specifically solve one problem, a spam filter, a chess engine, a recommendation system, each one built from scratch for one job. But post 2020, everything changed. Post 2020, AI is defined by one word, that scale. We went from narrow, task specific tools to systems that can understand, reason, create, and generate across thousands of tasks. The shift from narrow to scale is what makes today's AI feel like a different beast entirely. AI versus ML. What's the difference? Okay. Now, a lot of people use AI and machine learning interchangeably. Let's clear that out. Machine learning is a subset of AI. All machine learning is AI, but not all AI is machine learning. Think of AI as a big umbrella. Machine learning is one powerful tool underneath. Now, within ML, there are two fundamental different approaches I want to talk about: traditional machine learning models and foundational models. Traditional machine learning models, you define the problem, you define the possible outputs, the model picks from them. It was closed ended, you were always in control. Then came foundational models. These are open ended. Instead of selecting from fixed set of outputs, they generate new content, text, code, images, audio. They are not picking from a menu, they are creating. And that's fundamental shift that changed everything. This is also why foundational models can feel unpredictable. They are not constrained to fixed answer set. That's feature, not a bug. Now, how are these models trained? All right, so how does these models actually learn? There are three main paradigms, like supervised learning. You give the model the label data. For every input, you tell it the correct answer. The model learns from those labels, works, but it's expensive and time consuming. Someone has to label all that data by hand. But in unsupervised learning, no labels at all. The model finds its own patterns in the data, harder to control, but useful for clustering and discovery. Then the real breakthrough, self-supervised learning. This is what made LLMs possible at a scale. Here's what beautiful idea. The data labels itself. Like take a simple example. I love street food. So this is an example. From that one sentence, you can create multiple training examples like predict love from I, predict street from I love, predict food from I love street. One sentence, multiple lessons, no human labeling required. And when you scale this up to billions of sentences across entire internet, that's how you get a model with general intelligence. Now, training happens in two major stages. Pre-training, done on massive data sets, extremely expensive. This is where the model builds its base understanding of the world. Post-training and fine-tuning. This is where the model gets aligned to human preferences. It is trained to be helpful, safe, useful in conversation. Think of pre-trained as a school and post-training as a job training. When a model can generate flexible outputs across any task, we call it generative AI. So, this is the difference between unsupervised learning, supervised learning, and self supervised learning, and how this came across under the umbrella of our machine learning and AI. How do LLMs actually work? So, now we know how they are trained, but how do they actually generate text? LLMs are autoregressive models. That's a fancy phrase for something surprisingly simple. They generate text one token at a time, based only on what came before. So if you give it a prompt, the model does this loop. Look at the previous tokens, calculate the probability of the next token, pick one and just repeat. That's it, one token at a time over and over. And this is why it's expensive. Fundamentally different from traditional software, which computes everything at once. This is step by step generation, sequential, iterative. This also explains something you might have noticed. Responses are generated sequentially, latency increases with longer outputs. It's not loading, it's literally thinking out loud, token by token. This is all why LLMs can hallucinate. They are always predicting the most probable next token, not retrieving a stored fact. Sometimes the most probable next word is wrong. Now, what exactly is an LLM? Okay, let's zoom out and make this crisp. An LLM, a large language model, is simply a language model trained on massive text data with billions or even trillions of parameters. But what makes it beautiful isn't the size, it's generalization. Instead of training separate models for translation, summarization, Q&A, coding, you now have one model that can do all of them. Why? Because it has mentioned tasks. It learned patterns of language itself. It learns patterns of language itself. And language is the interface to almost everything we know. And that's the unlock. Here's a beautiful example. I just prompted I love spring and it's just popping up every other possibility it can think of. Okay, the next token ahead. Now, what's inside an LLM? All right, let's open the hood. What's actually inside one of those models? Tokens, embeddings, transformer blocks. Tokens, everything starts here. Everything starts here, yes. Text is broken into small chunks, words or subwords. These are tokens. Model never sees letters, it sees tokens, embeddings. Each token gets converted into a numerical vector, a list of numbers that represented its meaning. This is how model understand text not as words but as points in mathematical space. Transformer blocks. This is a core computation engine. Inside each transformer block, there are two components. Attention, that this captures relationship between words. It's what lets the model understand that bank in riverbank means something completely different from bank in financial bank. Feed forward layers. These process information further, adding depth to the model's understanding. Attention is the key innovation here. Without it, LLM wouldn't exist. Now, where does all the knowledge live? Hmm. Parameters. All the learned weights of the model, billions of numbers, adjusted during the training that encode everything the model knows. And finally, the output layer. This converts the model's internal representation into probability and picks the next token. Here's the mind bending thing. The model doesn't know the facts the way you do. The knowledge is distributed across billions of parameters. There is no single place where Paris is the capital of France stores. It's encoded implicitly in weights. And when you extend these models beyond text, images, audio, video, they become multimodal foundational models. Same architecture, bigger world. So to bring it all together, we can say AI is all about building intelligent systems. Machine learning is the tool. Self-supervised learning at scale is the breakthrough. LLMs are the result of autoregressive token by token generators built on transformers, embeddings, and billions of parameters. That's what's empowering everything you are seeing right now. In the next video, we are going deeper into AI agents, workflows, chaining, vector stores, embeddings, and even RAG architecture. If this was useful, drop a like. It genuinely helps. And I'll see you in the next one. See you soon.